Section 9.2 is about exponential functions. In Chapter 9, we'll be dealing with brand new type of functions, namely exponential functions and logarithmic functions. The definition of an exponential function is as follows. These are the type of functions which b, or sometimes in some textbooks they use a, is called the base, and x is called exponent. The difference is between these functions and polynomial function is the base is going to be constant. It's going to be number, but what? As you can tell from the equation, the exponent is going to be what? Variable. So either you have b to the x or a to the x. In both scenarios, what? You have so-called exponential functions. In some books they use b. I think in our textbooks they use a. A is the base. The only catch is there are restriction on these guys. A has to be positive and what? Cannot be 1. But x is any real number. So there is no restriction on x. But the base has to be positive and it cannot be equal to 1. Why is that? Because if the base is 1, 1 to any power is 1. So that's not an exponential function. It's a constant function. However, if b is negative, then x is any real number. What if x is 1/2? So this would be the same as the square root of -4. You and I, we both know that's not a real number. So therefore, the conclusion is the base has to be positive and it cannot be equal to 1. Any other number will do the job. So here are some examples of exponential functions. 2 to the x, 5 to the x, 3/2 to the x, 1/5 to the x plus 1, 2 to the negative x, y equals 3 to the x minus 1. These are examples of exponential functions. Okay, remember the base is a constant, but the power is where your variable shows up at. So one of the things we have to do is be able to draw a picture of these guys. Let's say we were asked to draw a picture of y equals 2 to the x. So I made a table here. So I'm going to find what? The value of y by replacing the x's in the equation in this function with -3, -2, -1, 0, 1, 2. Let's see what we get. This is 2 to the power of -3. It's not -6. It is what? 1/2 to the power of 3, which is 1/8. So exponential functions will never, ever have a negative y value. Y value always, whether the x is negative or positive, always comes up positive. If x is -2, this is 2 to the power of -2, which is what? 1/2 to the 2, which is 1/4. If x is -1, you get 2 to the -1, which is 1/2 to the 1, which is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. So the order pairs are -3, 1/8, -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. So these are the points I need to plot on the x and y axis to get the graph going. Incidentally, 2 to the power of -3 is the same as 1 over 2 to the power of +3, which is 1 over 8. That's how we got this. Do you see it? Okay, so -3, I'm getting what now? -1/8, very close to the x-axis. -2, still close to the x-axis, just a notch up. And let's say this guy, I'm just making this up. Let's say that's 1. So -1, I'm like 1/2 right about here. And 0 is 1. and then 1 is 2. Let's say this guy is kind of like 2. And then let's say this is 2, and way up here is kind of like 4. So if you put your straight edge here, notice the ruler here is not going to what? Go through a straight line. So the graph is not a line, of course. So you would imagine the graph looks like something like this. Do you see it? Okay. And notice it doesn't hit the axis. So make a note. Okay. Graph, what? Has no x-intercept. It just gets close to the x-axis, but it doesn't what? Crosses it. It just gets close to it. So when the graph goes up, as you go from left to right, we call this what? The graph is what? Exponentially increasing, yes? So exponentially growth. So that's what this is. Exponentially growth is the fastest increase in real life you can get your hands on. When something exponentially grows, that means it grows faster than anything else. All right? So what's the difference between 2 to the x and x to the 2? 2 to the x, because the base is constant, the variable is sitting at the power, is called exponential function. But x to the 2, the base is variable. What? The power is constant. So these are called what? Second degree what? Degree what? Polynomials. So do you see the difference between exponential function and polynomials? For exponential functions, the base is constant number, the power is variable. For polynomials, the base is variable, but the power is number. So that's the difference between exponential function and polynomials. Okay, what if now we have something like this guy? Y is equal to 1/2 to the power of x. Well, I got my usual values of x. So I'm gonna kind of like replace this x with -2, -1, 0, 1, 2, and see what I get for y. So this would be 1/2 to the -2, but 1/2 to the -2 is like 2 over 1 to the +2, just flip the fraction, and that would be like 4 over 1, which is 4. 1/2 to the power of -1 is 2 over 1 to the power of 1, which is 2 over 1, which is 2. 1/2 to the power of 0 is 1. 1/2 to the power of 1 is 1/2. And 1/2 to the power of 2 is 1/4. So the order pairs are -2, what? 4, is that right? 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. So the greater the x values, the smaller what? The y values. Let's see how the graph looks like. -2, what? 4. 1, 2, 3, 4 right here. -1, 2, 1, 2 right there. 0, 1 right about here. 1, 1/2, so right around here. And 2, 1/4. Notice the y values are getting smaller and smaller. As I said, if you put your ruler here on top of these dots, they are not gonna what? Go through a straight line. So you would imagine the graph is not a straight line. So what is it? It kind of looks like this. If you don't mind, let me just graph it, then I'll show you how it looks like. It looks like this. Do you see it? So once again, no x-intercept. Okay. And as you go from left to right, you walk on the curve. As you go from left to right, notice the graph falls. And we call these kind of graph exponentially what? Decay. Decay. Exponentially decay. All right? So this is the fastest what? Decrease in any function you can get your hands on. So the word exponential means fastest. So this is either fastest decrease, decay means decrease, gets smaller and smaller, and growth means what? Increase, gets what? Larger and larger, very fast. Such as what? Such as, God forbid, someone gets cancer, the cancer spreads what? In body exponentially. In other words, it just spreads out so fast. Bacteria also, grow so fast. They exponentially increase. Okay, so there are many word problems in real life, but the ones which I'm really interested for you guys to learn is called compound interest problems. Compound means interest over interest. Remember simple interest. That means you get interest one time and then you are out the door. That was I is equal to P times R times T. That was simple interest. But there are other kind of interest which is called compound interest, and that's like interest over interest. Like the interest on your what? Credit cards. If you don't pay the what? The amount this month, your bill this month, guess what? They're gonna attach a penalty. So they're gonna what? Take the interest of the next what? Month, add it to the last month, this month, add it to the last month, and then the interest is going to get compounded. It's going to accumulate, right? So it's interest over interest, and this formula doesn't work no more. Now we have a brand new formula, okay? It's A equals P times 1 plus R over N to the power of N times N. So there's a multiplication here. P is the principal, is the amount you have what deposited in the account. A is called accumulated amount. Okay, that's like future amount or future balance. R is the interest rate, which usually is given to in terms of percent, but it has to be changed into decimal. Okay, and N is the number of times the interest will be compounded per year. What does that mean? If they say interest is what? Compounded annually, N is 1. If they say interest has been compounded semi-annually, N is 2. That means you get interest twice a year, every 6 months. If they say interest has been compounded quarterly, that means N in the formula is equal to 4. That means every 3 months you get interest. If they say interest has been what? Compounded monthly, that means N is equal to 12 because we got 12 months in a year. Remember, this is compounded per year. All right, so let's do a compound problem, and that should do it for this section. If John invests $8,000 at 4% interest compounded quarterly, first of all, this is a compound interest. It's not simple because it says compounded. Second, quarterly means what? In your formula, N is equal to 4. That means you get 4 times interest per year. Okay, so that means every 3 months. Principal is what? $8,000. So that's your principal. Find the amount. That means accumulated amount is missing. And this is your T, which is 5 years. And this is your interest R, which is what? 4%. Is that right? 4%, which in decimal is 0.04. Just move the decimal point 2 places to the left and drop the percentage sign. So here's the formula. So this would be principal, which is 8,000, 1 plus 0.04 over 4, quarterly, to the power of N times T, which is 4 times 5. And that would be like 4 years, 5 years. And this T here, right here, where'd it go? Right here. T is the time, and it must be a year or a fraction of a year. So if they give you the time in terms of month, you have to convert it to year. Like if they say 6 month, okay, we cannot stick 6 here. You gotta what, convert this to year, which is like half a year. So you replace the t with 1/2, not 6. So in this case, you had 5 years, so you are okay because the t has been given to you in terms of years. So how do you do this? Well, you kind of go 8,000, what, 1 plus, this should be 0.01. 4 times 5 is 20. So this should be 8,000, 1.01. Add these guys and raise 1 point, what was it? 0.01 to the power of 20. First of all, let me make sure everything is a-okay here. Okay, so what did I do? First, I divided these two numbers. Then I added what? 0.01 to 1. So I got what? 1.01. I multiplied 4 by 5. I got 20. Now I'm ready what? To raise 1.01 to the power of 20. So 1.01 to the power, where's my power? Right here, 20. Okay, I get this. Don't mess this up. Just leave it. Okay, don't round this. Just leave it on the screen. But now take that answer and multiply by 8,000. Just go times 8,000. And now there you have it. So what's the answer? 9,761. And this is a dollar amount, so round this to the nearest what? Cents. So kind of like draw the line right here, round off the decimal. Because 0 is less than 5, so you drop all this and keep what's left. So the final answer is 9,761 bucks and what? 52 cents. Remember, when it comes to rounding off what? The money to nearest cent, you got to have 2 decimal places, not 3, right? 2 decimal places. So that way this reads, the future balance in that account will be 9,761 bucks and what? 52 cents. Provided what? The bank gives, or whatever the investment that he did, gives interest quarterly. So every 3 months, what? They add interest to this. After 5 years, 8,000 grows into what? 9,761 bucks and 52 cents. Hope that helps. Thank you.